Looks like very long since I see you again, but I was just giving this on Figma. So if you were there, hope that you like it. We will be starting with the second stream, which is building a rack system from scratch. Is one of my favorite topics to explain. So I'm really passionate about this, and hopefully I can transfer some of the knowledge that I've learned through the past months on these topics, so you can also be super experienced and then apply these concepts into your own projects that you're going to be building. Great. So let me just start. We have plenty to do today, and it's already we already have 11 minutes that have passed already. We only have 2 hours, so I'm gonna be rushing some of the things because there's plenty of content that we need to get through. Oh, hey there. Hi there again. Nice to see you again on the stream. We have plenty of hellos. That's great to see. Great. So, brief introduction for people that don't know me, because we always have to do this introductions. So, coach here at Major League Hacking. Fun facts: I like salsa dancing, and I like bee plushies in general to collect them. I am passionate about neurotech, so I like neuroengineering. That's also really cool. You can also follow me on Instagram. I dropped it in there. It's Jocelyn with the V and B. I'm kind of entering my influencer era, so I'm doing cool videos and edits. I might not get that far, but it's just for fun, and also to track all of my progress. And it's nice to see it in there, see those nice cute videos. Hi, are there any captions available? I'm pretty sure you can select them on the YouTube configurations. Hi, nice to see you. Hi again. Great. So we have a lot of people that are very excited to start this stream. So let's get started. Oh, I didn't update it. These it's not updated. But let me just mention what we're gonna be doing. So we're gonna be learning first what are vector embeddings. Then we're gonna be learning about what is a rack system. Then instead of using Pinecone, we're gonna be using MongoDB and LangChain with Gemini and embedding model in order to create our rack system. Then we're going to go into MongoDB and configure our vector search index. And finally, we're going to create a dashboard that we're going to be using Streamlit because it's one of my favorite tools. And we're going to be building the whole chat application here. My goal in here is that you have finished project in GitHub with a rack system, which is basically an AI chatbot using Python that has context in it. So the context that we're going to be searching from there. All right. So first things first, what is an LLM? So this is a very broad definition. I'm pretty sure we all know what an LLM is. You basically have some text input, then you have your language model, and then you have your text output. Um, you also can have the text output, it's numeric. You have a representation of text that is useful for other systems. And we have other hellos in here. Hi there, nice to meet you. Okay, so the first thing, the first stop that we're going to be doing of our stream is embeddings. So we can see in here an overview of the pipeline that embeddings follow. If there's anyone on the chat that knows what an embedding is, please drop your comment in there so I can see it. I'm just going to give 1 minute to see if there's someone who knows what an embedding is so we can explain it. And then I'm going to be explaining this graph in here as well. All right. Let's see if there's some comments in what you are typing. I don't know what to tell you. I don't have many stories for today because I haven't done anything today other than prepare the stream. So embedding are the numerical structure of the string or words, maybe. Yes, you are going in a correct path. Number representation of tokens. Okay, that's another way to see it. Breaking into pieces, hard coded. Okay, so there's many definitions, and I like how all of these definitions that you are using are complementing each other. So you do have a right for the semantic analysis. I like that response. Yes, it is for semantic analysis. So here's a pipeline of how embeddings work. You have a regular sentence such as boy is walking, girl is walking, and I am studying, right? So there's three different sentences in there. Then those sentences are passed on to an embedding model. This embedding model is just a way of converting those words into vectors, which are numerical representations of text as we see them in here. So we have a vector and we have different numbers in there that compose this sentence over here. And then those sentences you can actually graph them. As we are talking about embeddings and vectors, you can graph those vectors into a two-dimensional plane as we are seeing it in here. So this person that was talking about semantic analysis, you are completely correct. Why? Because boy is walking and girl is walking are graphed close to each other, while the I am studying one is up here because it's not very similar. And boys walking and girls walking is really similar. So this is the pipeline overview. I'm gonna be going step by step on this pipeline so you can understand a bit better about how this process works. But if you want to summarize it into like something broad, you can use this image as a reference. Then the next thing that we have in here is it's a concept called tokens or tokenization. If you were present at my stream yesterday, you would have seen that I talked about tokenization, and we even use a GPT tool to convert text into tokens. So tokenization is basically the process of breaking down words into smaller units that we call tokens. These words, they can be words, they can be characters, or they can even be subwords or empty or trailing spaces. We have a simple Python example in there. There's a text, I love programming in Python. Then we split that into tokens, and then we can see how the different words are being separated. Again, this is not the standard. So a token is not a word. There's different chunking techniques in order to like split that text. Yesterday, we were seeing one of the chunking techniques that GPT uses, but every system uses different chunking techniques. I was mentioning yesterday that the standard that you can compare of is that a character is roughly 4 tokens. So if you divide a word into 4 characters, then you can get the amount of tokens. But that's just a rough estimate. That is if you want a rough estimate. There's actually chunking methods that will allow you to separate tokens just as an AI is doing. Why? Because when you input text, ChatGPT does not receive that text. It receives tokens. And those tokens is the actual translation that we're going to be learning a bit more on how that process works. So far we saw the pipeline, then we saw about tokenization, which is also important. And here's a bit more of an explanation of tokenization. So it basically transforms human text into a format that all LLMs can understand, because at the end they're just machines that they don't understand human text. A tokenizer breaks down text into tokens and it converts them into numbers. So you have your words and it will convert that into numbers. And these numbers are the ones that are used by models to perform the calculations that we want. And these calculations is just an answer for us. So if I ask Gemini what is MongoDB, it will convert MongoDB into tokens, and then those tokens are going to be converted into vectors, and then the vectors are going to be interpreted by their model, and then I'm going to get a response back to me with the actual text that I can understand. Here's another example. We have an input text where it says, write an email apologizing to Sarah for the tragic gardening mishap. That sounds sad. Then you go over and do tokenization, and then you assign the token IDs to each one of them, which will be an array of vectors. And that's the stuff that your LLM will be interpreting instead of the actual strings that are in your text. So this is very important. Right? Then the next thing that we're going to be seeing is embeddings. And I have a question here. Is her voice cracking for anyone else? Please let me know. There's not much that I can do about the Wi-Fi. It's showing good on my end, but please let me know if this is an issue for everyone. so I can see what I can do. So for embeddings, they basically provide a way to represent complex data types. These complex data types, they can be text, images, or graphs. And these complex data types will be represented into a numerical format that a machine can actually process. Um, so yeah, this is just a really formal definition, but then I have more. I have a better explanation here. So we have no, it is for me sometimes, okay. It's okay for me too. All right, so I'll just continue and let me know if there's any technical difficulties on your end. Okay, so now talking about the importance of embeddings. So they capture the semantic relationship between data points. As someone was mentioning, it is for semantic analysis. So by reducing the data dimensionality, the computations are faster. What does this mean? That we can graph our embeddings, as I was mentioning, in a two-dimensional plane, and you can see how alike they are depending on their semantic meaning. So in here we have programming languages, right? So Python and Java, they're close to each other. Then we have royalty, queen and king, they're mapped close to each other. And then we have woman and man, which are mapped in gender, and they're also close to each other. So there's these relationships in here that you can basically graph, and you can see how they relate themselves. Okay, so now the question is, we already learned about tokens and we already learned about what embeddings are. So now how they are actually related. So once a text is tokenized, so once we actually chunk that and have our tokens, those embeddings turn the tokens into numerical representations that are called vectors. And we can see this nice diagram in here. We have this text, then we have our embedding model, and then we have the text that has been converted into a vector in here. So here's an example. The word king, so king might be represented as this list of numbers, right? So you can see, if you want a nice definition, you can just say that embeddings are a numerical way to represent words or like human text, if you would like to say so, um, like text represented as vectors. Now we have different types of embeddings here. You can have static and contextual embeddings. Some contextual embeddings are, for example, BERT and GPT. And it means that a word's vector changes based on the sentence that it is in. So if I have a sentence talking about food, and then the salad is going to be in the middle, and then we have a dessert in here, and it's mapped in here. The pizza is not, it's almost considered a sandwich, but not too much. The shawarma is mostly considered a sandwich. Then we have the hot dog, and the salad is just in the middle. So this is how embeddings work. You can relate the words into their semantic meaning. And here we're just talking about food, right? So if I were to plot in there spaghetti, maybe that would be somewhere between liquidness and sandwich as well. And then if I were to plot in here ice cream, then it might be on the liquidness, dessertness side, because the ice cream is liquid, but it's also a dessert. So it will be plotted in there as well. Hopefully this graph is helpful for you, so you can see how these words are being mapped into embeddings and how you can actually plot those embeddings into a two-dimensional plane on your application. All right, so here is a more complex cloud about vector embeddings. So some applications of embeddings, you can use it for semantic search, which is basically what we're going to be doing today. We're going to be using it for semantic search. So I'm going to be asking my chatbot a question, and then I want to get similar responses from my database on that semantic search. You can also use embeddings for recommendation systems. That's also another thing that you can do. And you can also then use it for multimodal applications. So multimodal applications, we're talking about images, we're talking about videos or files or something that is not just regular text. So now, let's see what's next. Okay, we're going to be understanding some of the basics math that we're going to be seeing in here. And we have a question in here. How is the n element vector represented as in 2 or 3-dimensional space? I don't think I'm getting your question. If you would mind rephrasing it so I can understand it. If you're meaning why this one is 3-dimensional and then the other graph that I showed was 2-dimensional, it depends. Depending how many categories you want to map your embeddings. Let's say I have 4 different mappings, or I have like 5 different mappings. It all depends on that. But if you wouldn't mind rephrasing your question, I might take a look as well. Okay, so now to understand a bit of the basic math on what's on the backside of these vector conversions, what is the explanation on these numbers? So we're gonna be seeing that. So vector embeddings are, of course, related to vectors. And in a math, a vector is a set of numbers representing both magnitude and direction. This is just some simple stuff that we saw when we were in primary school, and we all understand this, right? So if you're talking about vectors, you are talking about physics, but then there's also this other term called vector embeddings that it is nearly related, because you can also plot it, and it also has a magnitude and a direction as well. Then there's also complex vectors, and as developers, we basically think of vectors as an array of numerical data, right? So we have like when you are doing, I don't know, a lead code problem and you need to create a vector, then you can think of that as an array of numerical data. The only thing is that a vector can change in space, and an array has a fixed space in memory, right? So these are complex vectors, as most programmers know it. Like if you define a vector in Python, or if you define a vector in JavaScript, or whatever programming language of your choice that you have. So that's the main difference. And then there's this important term that's called cosine similarity. We're going to be learning about that today. Cosine similarity is mostly to measure the similarity between two vectors. And this is how actually we get the responses for our recommendation system and our RAG system. Because I just want to be clear about what we're going to be developing today, if it's not clear enough right now. So what we're going to be doing today is that we're basically going to be building a chatbot, but that chatbot is going to have a vector database. So it's going to be having a database full of vectors that we're going to fill with data. And then let's say that I ask my chatbot a question like something personal about myself, like where was Jocelyn in 2015? So a regular LLM won't know the answer to that, but a RAG system will actually know the answer to that, because it will have information stored in this vector database. So in order to make that relationship between two vectors, so to calculate the relationship between two vectors, you want to do this calculation that's called cosine similarity. There's other different calculations that you can use in order to measure the similarity between vectors, but for this stream, I'm going to be focusing on cosine similarity. So there's a formula for cosine similarity. It basically calculates the cosine of the angle between the vectors, which represent the direction in a multidimensional space. So as we were seeing, if I go back really quick, so in here we have plenty of vectors. So let's say that we want to look up for the relationship between a point in the red cloud versus a point in the brown cloud. So in order to get that relationship between those 2 points, I'm going to be wanting to apply this formula that I have in here. We're just doing AB. A and B are my 2 vectors. Then we apply a dot product operation, and then we measure the magnitude, which is the length of the vectors, and the outputs are going to be values between -1 and 1. So depending on the relationship that we're going to be having. And that's just how you measure the relationship between 2 vectors on a multidimensional space, as we already saw on our previous graphs in there. All right, so before we move on to the RAG system, we're going to be creating our own embeddings. So for these, we're going to be using Hugging Face, and we're going to be using the sentence transformer model, which is to convert to embeddings. You can access that in here. And then we have a question. How would you interpret the results of cause and similarity? I only know that they vary from -1 to 1, but I honestly, right now, I don't know if 1 means like 100% accuracy or like not so much accuracy. It's something to look up, definitely. But we can actually find out that once we start doing the code, we can print the result of cause and similarity to see how alike they are. I believe that getting like 0.80 something, it's really good, but that's just my reference by doing it. But I actually don't know if that's like if I'm correct on what I'm explaining in there. But yeah, they vary between -1 and 1, so you will never be seeing values that go from 2 or 3 or a bit more. Yes, of course, no worries. So please make sure to enter that link. I'm not gonna be doing like these complete code. It's just a reference that you can use. Let me also share that one. Um, so let me just start this one. I'm just gonna show you how it looks like and explain you a bit broad what I'm talking about, but I'm not gonna be like running everything. So hopefully you are already seeing this one on screen. Let me make this a bit bigger. And I'm gonna close this output. So in here we are just installing the sentence transformers, right? Which is a library that we're gonna be using. We import that, which is from Hugging Face. So people that don't know what Hugging Face is, Hugging Face is basically a hub, like GitHub, where you can publish your open source models or other tools that are helpful for developers, specifically for AI and machine learning, which is really cool. And there's also a couple for computer vision as well that you can find in there. And everything that's in there, it's open source, so it's also really cool to see. In this case, we are selecting our embedding model. If you remember from our slides, you need to select an embedding model in order to transform your text into vectors. In this case, I'm selecting this embedding model. And then the next thing that I'm going to give it a couple sentences. So vanilla ice cream and chocolate pizza. And then I'm generating my embeddings in here, model.encode, and then I'm passing on the sentences. And then I'm just printing the embeddings in here. And if you can see, they're just much arrays in there of all of our vectors. It's really long, right? So all of these numbers are the numbers that are going to be using in order to calculate the cause and similarity. So we have vector A in here, and then we have vector B in here, right? So in here we have two vectors. So we have this vector over here that ends in here. And then we have the second vector in here that starts all the way over here, right? So two vectors in total. I'm not sure if let me see, run it away. Let's see if I can just run it to see. Oh yeah, no, I will have to install everything. Let's see. You can also try running these. I'm not doing this because the sentence transformer library takes a while to load, so I'm just going to leave it like that. But you have the example, so feel free to play around in there. Thank you. Yes, no worries. 1 is extremely similar. -1 is extremely opposite, if I remember right. Okay, yeah, then that will make sense on why I'm always getting like 0.80 when you make the cousin similarity. Thank you for the clarification. Is it possible to get a recording of this live stream? Yes, that will be published into the YouTube channel under the live tab of Major League Hacking. So if you look up on YouTube Major League Hacking and then go under the live tab, you should be able to see this recording once I end the stream. They have recording sessions on YouTube, I guess. Yes. Thank you for clarifying. Can you share the link? The link for the code, I already shared that. It's mlh.link /embeddings. Okay, and then yes, no worries. Then we have another question. Sorry. My original question was, how is such a long vector being represented in a 2D or 3D space, if it makes sense? Huh. Honestly, I have no idea. I wouldn't know. I know that doesn't answer your question, but I don't know everything, so that will be something to research. But yeah, thank you for asking and also questioning myself, I will definitely research so I know the answer. I think n element vector have the n dimensional representation. That sounds that makes sense. Because yeah, there are multi dimensions, so it means that it can vary depending on how many elements you have. Hopefully that makes sense. And yeah, thank you, Morpheus, for giving us a hint in there. Yeah, for sure. All right, so I already shared the code in case that you want to generate your own embeddings. Why? Because I want you to get your hands on working and not only just me talking about embeddings and then you saying like, oh, how do I actually generate them? So that's why I shared that helpful Google Colab code that you can look up and also learn from there. All right, and yeah, I think someone just shared the YouTube channel. Thank you very much for sharing that. Great, so let's move on. All right, so now we already learned about what vectors are and we already learned what embeddings are. So before moving on to rack systems, can someone explain me what an embedding is? And you can drop your answers on the chat. So the question is, what is an embedding? Depending on what we saw today, what is an embedding? I'm just gonna give you a second, and then we have this questioning. Oh, we have another comment, but typically they are represented in 2D or 3D space, and from the code sample we saw, it is not possible to visualize a vector that long. I like this side conversation. It's very smart. They are used to capture the semantic relation between data. Okay, yeah, that's really accurate. Converting text to numbers, yes, that's a summarized version. An embedding is a numerical representation of text which could be contextual or static. That's a very accurate one. I like that one. Yeah, sure, you are correct. Okay, I guess this one is an answer for this one about the representing in a 2D or 3D space. Then we have another definition, a numerical representation of text in 2D or 3D scope or space. Okay, great. Numerical representation of text. Okay, I think a lot of people are getting what embeddings are. I really like that. A representation of data in an n-dimensional space. Awesome. So hopefully the definitions that all of the hackers were giving are helpful for those that are still struggling to understand these concepts. I know that understanding all of these might be a bit overwhelming. There's a lot of maths on the backside, and there's a lot of things going on in these models. So it's nice that I'm seeing that you are all getting these explanations. An embedding is a numerical vector that represents complex data. Yes, you are correct. And then, not sure if it's related, but PCA is used to reduce the number of variables and visually represent them in a 2D or 3D space. Nice. So we have someone that knows about machine learning. That's really cool. Okay, so glad to see that there's many hacker interactions on the chat. Again, if you're still struggling to understand these concepts, we're going to be learning a bit more about rack systems, which is what we're going to be doing today. I promise you the code is super simple, but then if I only do the code and then don't explain what's on the backside, then it will be a bit more complex, like to start explaining everything out from the code. So it's better to see these nice diagrams and structures and to understand how it actually works. Again, the recordings will be uploaded into our YouTube channel. So if you still are a bit confused, feel free to watch the recording further along, or you can also always DM me on my Discord account as well. All right. Are embeddings and vectors same? No, they're completely different, but you represent embeddings as vectors, numerical vectors. That's the only difference. I mean, they are related, but a vector in Python, for example, is a vector. So you have different numbers that you can store in that vector. So instead of storing like 1, 2, 3, you store the embeddings that you're going to be using. So that's a relationship. Hopefully it's a good explanation. Okay, and then we have another comment in here. Embedding is a numerical vector representation of text. That's good. No, embeddings are vectors, but not all vectors are embeddings. Okay, I guess that's also another way of saying it. What's the difference between vectorization and embedding? Oh, that's a nice question. So I would say vectorization is mostly just converting this, and embedding is the number that's inside our vector. Not sure if that answers your question. Um, you will explain the architecture of RAG? Yes, I will. I will continue along, and then I will be answering your questions on some free time. So to get into the RAG systems, RAG is Retrieval-Augmented Generation. Here is the definition from Geeks for Geeks, which is a page that I really like. It is an innovative approach in the field of natural language processing, NLP, that combines the strengths of retrieve-based, blah, blah, blah. We don't understand anything from there. Honestly, I don't understand that text. It's just really weird. So let's just dive into a RAG in simple terms, right? So RAG in simple terms, we have a nice diagram in here. Let's say that you want to give your chatbot a brain to search knowledge from, and it can also be a library of information to look up for. So in here, this pipeline is really self-explanatory. So we have a user, right? This user could be me, this user could be you, or anyone. We make a prompt, which is a query. Then we have our retriever. This retriever, it searches on our data source, which is our vector database. If there is relevant text, then that relevant text is being sent back. And then we have our LLM. The LLM can be Gemini, it can be GPT, DeepSeek, any LLM of our choice. And now we sent out the prompt plus the information that we fetched from the data source. Finally, the LLM crafts a nice response, and that is what we are getting. So RAG systems are not for every application. So you can design a RAG system to answer specific questions about a very niche topic. So let's say that I want to make a RAG system about my life. So I will create a data source with information about my life as Jocelyn, and then I will convert that data into embeddings. So now when the user asks a question to that chatbot, the chatbot can answer with context about myself. Why? Because if I were to shut up the data source and not access the data source, I will only be accessing the LLM, and well, the LLM won't have information about my life. So that's the difference between just doing a regular prompt, a regular query to your LLM, and the difference between having a knowledge base where you have your RAG stored in there. And yeah, hopefully this pipeline is like nice, so like you can understand it. But I'm also going to be explaining a bit further along. So here is the actual definition of where the RAG come from. So RAG, or well, the R is basically look up the external source to retrieve the relevant information. Then we have the A, which is add the retrieved information to the user prompt. And then we have the G, which is use a LLM to generate response to user prompt with the context. So again, it's the same pipeline. It's only a bit changed with more technical concepts. So we have the user and then we have the prompt, right? So the user is gonna make a prompt. Then we're gonna do the R. So the R is gonna retrieve information from our context. Then we're gonna augment that. So we're gonna join the prompt plus the context that we just fetched. And we're gonna input that into our LLM. And the LLM is going to produce a response for us using that context that was previously provided by the database, or the vector database that we're going to be using. Okay. Yeah, so now how does this actually connect with a regular chatbot? And hopefully you like the B that I generated using Nano Banana, which is really nice. So to connect this knowledge that we just learned, you can connect your chatbot to a knowledge content. This content can be a PDF, or it can be a .csv file, or just a .txt file. So it's mostly just knowledge that you want to input into your chatbot. And now the chatbot will answer in context with the PDF we basically uploaded. So I don't know if you've been in this situation where you have, where you are studying for something for school, and then you have your chatbot like ChatGPT or Gemini, and then you upload a school presentation in there. And now the LLM will basically respond to you in base of the presentation that you just uploaded to their system. So that's what we're going to be building today. We're going to be building a knowledge content, and we're going to be getting answers in relation to that context that we recently just context that we just uploaded. And that's how it connects with a regular chatbot as we know it. Okay, and the libraries that we're going to be needing in order to build this, and I forgot to change, we're not going to be using OpenAI, we're going to be using Gemini, because OpenAI is, you have to pay. And for Gemini, it's completely free, so we're going to be using the Gemini models. We're going to be using LangChain, which will be the brain of our chatbot and the whole building process. To be honest, I'm not a very experienced person in LangChain, but I recognize that it is a complex tool in order to incorporate everything related to LLMs and chatbots. So it's a really cool library. We're going to be using Gemini, which is the LLM that we will be using to generate our responses and also to generate our embeddings. And finally, we're going to be using MongoDB, which will be our vector database to store the knowledge. I'm going to be explaining a bit more on what do I mean by storing knowledge, but basically all of the information about myself will be stored in MongoDB, which is a vector database. Well, MongoDB is not natively a vector database. They have vector indexes that you can use to do embedding searches. So just to be a bit clear, MongoDB is a non-relational database, and you can use it for regular stuff about databases, but it can also be used as a vector database, which in my opinion is really cool. All right, so now we're going to be seeing the step-to-step process followed by RAG. This one is in simple terms, and then we're going to be seeing one that's more in technical terms. So the step number one is that you're going to ask your chatbot a question. This question can be, what is my favorite hackathon, right? So that's going to be my question. What is my favorite hackathon? Then the step number two will be RAG starts the action and scans the PDF that we uploaded to match our question. And then the step number three will be that with the most relevant information retrieved using RAG hands the information to an LLM. So once that we fetch that information that we retrieved is going to be fetched into an LLM. And number four, the LLM now uses the factual information that we just input plus generation to tell me that my favorite hackathon is, well, all of them. So that's how the pipeline works in very simple terms. Now let's see them in more technical steps, right? We have a question. Are we using Streamlit? Yes, we're going to be using Streamlit for the dashboard just because it's super easy. And it integrates directly with Python. So the technical steps, again, number one, we are going to be doing query understanding. So breaking down the user's question into tokens, analyzing the semantic meaning of those words. Number two, we're going to be retrieving from our knowledge base. So RAG interaction with a database like MongoDB in our example. Number three, MongoDB doesn't actually store the text, but meaning-based mathematical representations of information called vectors. So in MongoDB, we're not going to be storing our text. We're going to be storing these vectors. And then number four, the RAG will generate a similar vector for the user's query matching. And finally, the answer is enhanced with LLM retrieved with a model like OpenAI, Gemini, or DeepSeek. So these are the technical steps that are used in order to generate our RAG pipeline, and we're going to be doing all of that today. We have 1 hour. Hopefully we can make it. I'm gonna be trying to pace myself up so we can finish the project. What is this? This is another diagram about how a RAG system works. We have a user in here, then we ask the question, then we have the embedding model, then we have our dense vector, then we apply similarity search. We search into our vector database. We fetch the information that's similar. We input that into a prompt, then we pass that prompt into the LLM, and then we produce an output. I would say this is one of my favorite diagrams to represent a RAG system. So just for you to keep in mind, this pipeline basically summarizes everything that's there to say about RAG systems. Okay, so moving on to LangChain. I'm not gonna be diving into a lot of fundamentals in the code, so I'm just gonna be doing that super quick. But I'm going to be explaining the important parts, like where is the embedding process happening, where is the MongoDB storing happening, where is the cosine similarity happening, and finally, where is the actual rack system happening in the code. Just for you to understand, LangChain is a Python-based framework to simplify the development of applications that are powered by LLMs. This is kind of the standard. It breaks down complex LLMs interactions into reusable blocks like chains, agents, and prompts that we can use. Chains are pipelines that connect components within the chatbot architecture. So instead of using like all of the different tools, we're going to center everything in LangChain. So we're going to be using the LangChain library to interact with MongoDB, with Gemini, and with all of the other tools that we're going to be seeing today. Okay, so now we're going to jump into the project building part, and we are just in time to set up our environment for the rack creation. So the first thing that we're going to be doing, we're going to create an account in MongoDB in case that you haven't. We're going to set up the base cluster. Then we're going to set up our index for the vector search in MongoDB. We're going to be creating a database and a collection in MongoDB directly on the UI. The next thing that we're going to do is that we're going to check the embedding model that we're going to be using in Gemini. Then we're going to be installing all of the needed libraries in Python that I'm going to be sending over on the chat. Then we're going to start with the dashboard that we're going to be building. And finally, we're going to create the backend code that we're going to be using. We have a question here. I'm going to sleep. I need a fresh mind to actually consume this. Yes, if it's really late where you are based, please go to sleep. Sleep is very important for you. And yeah, there's a recording, and I will be sharing the GitHub link as well, so you can also have it. Okay, so I want to be now stop sharing my presentation, and then let's see. I'm going to be using this one. Okay, I'm going to be using this tab for everything now. So I'm going to share this one as well for MongoDB. So please go ahead and create an account in MongoDB. I'm just going to click on Get Started. I already have an account. I'm just going to log in. So definitely take your time to do this to create an account. And once that you are seeing this dashboard, it has to be pretty similar, maybe a bit different. We're gonna continue. So I'm gonna give about 5 minutes for you to create your account in MongoDB, because this is gonna be the base for everything. And once you're done, please let me know on the chat. All right, so I'm seeing that plenty of people is done, so we're going to be continuing. I gave a bit more time for this because this one's really important. Awesome. So now let me remove this banner so we can continue. And let me swap to that screen. All right, so for MongoDB, there's a lot of things that we're going to be doing on this dashboard, so let's follow along. So the first thing that you want to be doing, if this is your first time using MongoDB, then you want to make sure that you have your cluster connected. If you have never created a cluster and you have a free account, I also have a free account, so that's what I'm saying this. You will only have the right to generate one cluster. So if I were to click in create, if this is the first time that you're doing it, you're gonna be seeing an option that's for your free cluster. So just leave the default configurations and then just click on create deployment. In my case, I cannot do it because then it will charge me and I don't want to do that. But if it's your first time doing it, then you're gonna be seeing one that says free in here. Um, all right, so once you create your free cluster, then you should be seeing your cluster in green in here, which means that's already that it's active. Why? Because the cluster is where we're gonna be doing like all of the processing in there. Hi, I was unaware of the sheds. What are we supposed to do that right now? So right now, we're just creating a MongoDB account and we're just about to be setting everything up. Nope, we haven't started with the project. We are just starting, so you're just in time. Awesome. So the next thing that we're gonna be doing, we're just gonna be seeing stuff, right? So I'm gonna click here and connect because we want to connect to this cluster. And there's several ways that you can connect to this cluster. In our case, we're going to be using the drivers one. So drivers, then you can select the version of Python that we're going to be using, or you can select like any other language of your choice, and the version of Python that you're going to be using. And here it says how to actually install the PyMongo driver that we're going to be using with pip install. And then it shows you this important string, which is the MongoDB connection string. So this string, you can see it as an API key. So this string will have all of the valuable information that we want to use. And if we click in here to view full code, we can see actually an example of how to verify that MongoDB is working for us. In this case, we have our URI in here that has our DB username, that you need to replace this with your actual username and replace the DB password with your actual password. If you don't know what your password is, I'm going to show you in a second because I also forget every time. So you can change it as many times as you want and also check what your username is. Keep in mind that this is sensitive information, so we'll be storing this URI on a .env file or on a secrets file that we're going to be creating later on our project. Right now, I'm just basically showing you how to connect to MongoDB. There's nothing for you to do on your end, just to know that in this section, you can fetch your MongoDB URI, which is this one. In the meantime, I'm just going to close this. I'm going to click on done. And then to change your password, if you don't remember your password or your username, you're going to be click on here on database and network access. Then we have a question here. Yeah, 53 minutes into it, I had to create a database user first. Yes, that's correct. You need to create a database user. In my case, I have a couple in there. I have this one that's for a specific cluster. Then I have the main one, which is this one. If I were to modify these, I can click on edit and then on password, and I can edit the password in here, right? So if I click on edit password, I just enter the password and save that one. Make sure that you click on update user. So in my case, I'm gonna be editing my main one, and then I'm just gonna change it because I don't mind. I'm gonna be typing 1, 2, 3, 4, 5, 6, or I'm gonna change that. All right, so hopefully it will let me. I'm gonna click on update user, do an update, and then it says we are deploying your changes. So we just have to give it a while until it does the actual password update. What did we choose at connection method? Yes, driver, but it's only for you to look up for the URI. I'm going to be repeating that step when we are in the code. Right now, I'm just basically giving a brief overview of what are the information that you're going to be needing to fetch from the MongoDB dashboard. Yes, it's a driver. Driver is a connection method that I used. Okay, so now it looks like my cluster is being set up for these usernames. So I'm going to go back from database access. I'm going to be moving to clusters again. Um, okay, so now that we know how to fetch our MongoDB URI, which is the URI that we're going to be using to connect from the code, and now that we know how to change the password and fetch our username, I'm going to be heading back into Gemini so we can see which embedding model we're going to be using and what is the vector dimension that we're going to be selecting for our vector search. So I'm going to go ahead and enter the Google AI Studio. Um, I'm going to be sharing that link as well. Link AI Studio. Okay, so the second thing that we're going to be doing is that we're going to be exploring the Gemini API. So another thing that you are going to be needing is an API key that you can select it from the Get API key. So I'm just going to give you another 5 minutes for you to log in into AI Studio and create an API key. I can share you also the exact link for that one, which is this one, to fetch your API key. Again, I'm going to give you 5 minutes for you to create an account, create AI Studio account. Okay, so create AI Studio account and a free API. And let me know once you get that. The API, you can store it in a TXT file because we will be using it in a while. Imported project or default project. Select the default project. Yep. All right, so looks like we're gonna be continuing, and yes, I will accept your LinkedIn requests. I'm just doing that. There's so many in there. Yeah, awesome. So that should be done. I missed the sessions yesterday. One can watch recordings. Yes, they're on our YouTube channel, Major League Hacking. You can find all of the recordings in there, as well as this one that will be uploaded once I finish the stream. Let me hide this banner and let's continue. So once that you created your API key, I won't be creating a new one because I already have plenty created that I can use from. The next thing that I'm going to click on, I'm going to click on these uh, quick start guide of API. It's in Spanish, but you should have the same button. So I'm going to open up that one. And now we are actually seeing the Gemini documentation. So Gemini API Quick Start. Here is the package that we're going to be needing to install. I'm going to share you the requirements that we need because there's a couple of them. So don't worry about this one, how to make your first request and so on. So in here, we're going to be seeing on our lateral sidebar on the left, there's these other models. There's this one called embeddings in here. So we're going to click on embeddings, and then we can see the different Gemini embedding models that we can use. So this is one model in order to generate embeddings. There's different techniques in there to do multiple chunks at once. And then what I'm looking in here is for the size of the embeddings that we're going to be using. So it says by default, it outputs a 3072 dimensional embedding, but you can truncate it to a smaller size. We recommend using a 768 and these other output dimensions. In our case, I'm just gonna pick this one as a personal preference, but you can use any other dimension. Why? Because I'm gonna be needing this number in order to create my vector index in MongoDB. Let me see if there's a question. Thank you. Yes, no worries. All right, so now that we know that this is the model that we're going to be using and that our vectors are going to be needing to be 768 of size, I'm going to head back to MongoDB and I'm going to create that search index. So to do that, I'm going to create a database and a collection. So in order to do that, I'm going to click in here on clusters, and then I'm going to click on browse collections. It's going to load all of the different collections that I have. I have plenty. If this is your first time using MongoDB, then you should have like a default database. In my case, I will be creating a new one for the purpose of this stream. So over here in this button, you're going to click on create database. I'm just going to call these vector store database. And the name of my collection will be embeddings stream, because I'm on the stream. Just for me to know. You can name these whatever you want as long as you remember them, but you can always look up and search them. After that, that I created my database name and my collection name, I'm going to click on create database. All right, so now this database is empty, so it has no data. We can see the database in here, and we can see the collection in here. That's called embeddings stream. And in here is where all of our vectors are going to start appearing once we start filling our vector database, which is where we're going to be fetching all of the knowledge. All right, so now that we created our database and our collection, I'm going to head over in here and now move on to search and vector search in here. Search and vector search. So once that I'm on search on vector search, I have a couple in here already created. I created this one just for testing this morning, but I'm going to be creating a new one. So, I have reached the limits. Okay, I'm just going to delete some. I'm going to delete this one, delete index, drop index. Okay, there we go. So the free clusters have a limit of 3 search and vector indexes per cluster. I already used 2 out of 3, so I'm going to be creating a new one for you to see today. I'm going to be creating this search index, and let's see all of the different configurations that we need to fill out. So for the search type, instead of using Atlas search, we're going to be using vector search. Why? Because this is for semantic search and AI applications. So vector search, then we're going to scroll down. For the index name, yeah, we can call it vector index. I'm gonna place Global Hack Week, so I remember that this is for Global Hack Week. Then for the database that I want to pick, is this one embeddings database? No, it's not. It's called RAG database. Nope. Vector store database. Yep. Embeddings stream. In here, you're just gonna select the database and the collection that you just created. In my case, this is the one that I created, vector store database, and the collection that I created is embeddings stream. So I just selected that one and that's done. Then I'm gonna continue scrolling. I'm gonna choose the visual editor, but you can also use the JSON editor in order to define your index, but I'm gonna be using the visual one, so we go step by step. I'm gonna click on next. For the path, I'm just gonna say vector, and then the number of dimensions in here is what we searched up in the documentation from Gemini. So 706.8. So I'm gonna copy paste that number and paste it in here because this is the dimension that my vector is gonna be having. And then, no, my bad. In path, it's embedding. Path, field containing array of vector embeddings. Yeah, call it embedding. So you can name it the way that you want it, but I recommend placing embedding so you know that we are referring to an embedding. But this is just like a variable name, so you can change it. But I recommend using embedding. Then for the similarity method, this is what we already saw. We're going to be selecting cosine similarity. There's also in here a guide on how to select the right similarity method. In our case, there's several that we can pick from. I'm going to be using cosine similarity because it's the one that we were seeing right now. And that will be all. Once that we set up these, I'm going to click on next. And we can see all of our configurations for the review. Let's see. So we have vector path is going to be called embedding. The number of dimensions is going to be 768 because that's what the Gemini API documentation says. And similarity method, we have cosine. So we're going to create vector search index. There we go. And now it says that it's pending, but in a while it's going to be ready. And now we are ready to use this vector search. And with that, we will be already converting our regular MongoDB collection into a vector store database. So I would say that's almost all of the configuration that we need to do on the side of MongoDB. So while this is being deployed, I'm going to share with you the GitHub repo that we're going to be using. And I'm going to also share my screen on my VS Code so you can see step by step on what we're going to be doing. Let me just commit this. All right, so let me share that GitHub repository. Can you show the Google AI Studio configuration again, please? So I didn't do any configuration. The only thing that you need to do is create an API key. So in here, just click on create API key, assign a name, and select a cloud project, create the new project, or select a project that you already created. And then with that, you will be getting your API key. And I also send the link for the Google AI Studio on the chat as well. All right, so is it okay if I send you connection request on LinkedIn? Yes, that's completely fine. All right, so I already shared with you the repository in there. I'm gonna be committing all of the code that we do for the session in there. There's no need for you to clone the repository. You can just copy paste the things that are in there, or you can just see the updates. I would recommend if you could create a new GitHub repository that you can start working on. What did we do before the use vector search thing? Not sure what you're referring to. Can you clarify a bit more on the question, please? Thank you. Yes, no worries. All right, so I'm gonna give you the dependencies that you need to install. So I'm gonna stop sharing this screen. And now I'm gonna be sharing screen with the code. All right, here we go. And then, yeah, before setting up the vector search, we created something by going to browse collections in clusters. Oh, yes, you need to create let me type the instructions, create a database and a collection in MongoDB so you can select it from the vector. There it is. That's the instructions. Yes, you need to go to browse collections. Then you're going to click on create database. You're going to assign a name to the database and then a name to the collection. You're going to click on create. And then once you do all of the setting up the vector search, you're going to select that database that you just created. Hopefully that was clear. I also send instructions in there on the chat. Okay, so now that we have the code in here, these are the dependencies that we're going to be using. I also shared with me the GitHub repository on the chat where I have this exact same code that I'm using. So this exact same setup. So I have a backend file, I have a home file, git ignore. I also have a README that I still haven't finished and the requirements. So please make sure to install all of these requirements. To install all of the requirements at once, let me share with you that's to install it, all the requirements I want on the chat. Pip install our requirements. There we go. So you're going to use these to install all of the requirements that are on the requirements.txt file. I'm going to do that myself, and then I'm just going to give you I'm going to give you a couple of minutes for you to set up your VS Code, create your repository in case that you want to copy paste these requirements into your own project so you have everything set up and also install all of these. And I'll be back. Please let me know once you installed all of the requirements and you have your project set up done on VS Code. All right, so hopefully that was enough time for you to set up the project, and I'm seeing that my installation failed somewhere, so I'm also going to be checking that. I'm going to stop the ticker in there. Okay, so looks like everything was installed correctly. Then what is this error? Peeps dependency yourself, blah, blah, blah. You have Google AI, which is incompatible with all. Okay, once we start using that, we'll get to solve that problem once we get it. So once that you installed all of the dependencies that are needed, we're gonna make sure that we have all of the credentials that we need. So the two credentials that we're gonna be needing is the MongoDB URI that we already know how to get it. It was from the connection, and then go to drivers, and then select the URI, and then just copy paste it, and make sure that you replace the DB username and the DB name in there. And then the other thing that you're going to be doing is that you're going to be pasting your API key from Gemini as well. So I'm going to go ahead and create a specific folder that's going to be inside here. This folder is going to be named .streamlit. We need to name it exactly like this because we're going to be using a Streamlit, and this is the way that Streamlit stores like all of the dependencies. Sorry, all of the secrets. And inside the .streamlit, we're going to be creating a file that's named secrets.toml. So the first thing that we're going to, this is just like a .env file. So Mongo URI, and we're going to doing the equal, your MongoDB connection string here, and then Gemini API key. So this is exactly how we're going to be doing it. We're going to paste in here our connection string, and then in here our Gemini API key. So I'm going to go ahead and do that. I already have my API key in here. I don't mind using my API key because I'm just going to revoke it, and it's also the free one, so it doesn't matter. And then for the Mongo URI, I created a specific profile for the stream, so it's also okay if you see my username and my password. I don't mind. So let me just fetch that. So I'm going to go into... I'm not sharing that screen because we already know how to do it. I'm sharing only the code. So you're gonna fetch you're gonna go to clusters, you're gonna click on connect, then click on drivers, and then in there you can fetch your MongoDB username. So I'm just gonna copy paste this one. And I already selected this one, paste it in here. And my DB username, I already know that it's these. And my DB password, that's I set it up as 2027. Awesome. So that should be all. We have our two credentials, our Mongo URI and our Gemini API key. So we're all set, right? Hopefully you are doing the same. Then the next thing that we're going to be doing is that I'm going to add this folder into my git ignore so I don't actually commit this. So to do that, I'm going to do /streamlit. So I ignore all of the folder that's in there. Why is it not? Maybe like this. Okay, I'll check that later. We have a question here. Could you tell me again where to get the Mongo URI? Yes, so you're gonna go to cluster, then you're gonna go to connect, then you're gonna go to driver, and then look up for the URI there. So there's instructions in there. All right, so then what we're going to be doing is that we're going to start building our backend code that's going to be on the file that's named backend. So let me open up that section. I'm not sure why this one's not. That's interesting. Okay, so for the backend, we're going to be using a lot of imports. I actually have these on another file, and I'm just going to be copy pasting these ones because I honestly don't know these by memory. I'm just gonna paste them, and I'm gonna make sure that I upload these into the GitHub, so you can also see this exact same thing, and you don't have to copy paste it like once by once. But in here, we're just seeing all of the important stuff. We're not gonna be using .env. We're not gonna be using OS. We're gonna be using PyMongo, LangChain, MongoDB, many other things in there. We have another question here. Launching Google Gen AI could not find a version. Which Pi version is being used? I think I'm using 3.11. Might be wrong though. Yeah, I have 3.11 on mine in here. Oh, I know why. I was installing my dependencies not on my .bmb file. I was installing them locally. Whoops, my bad. I won't install them again on .bmb file. Oh, cd raga template. There we go. Okay, yeah, because this terminal was still not updated with the virtual environment, but this one is. So that's why all of my dependencies were being like not installed, but now they are going to be installed. I'll just give it a couple of minutes. In the meantime, I'm gonna upload these into the GitHub. I'm only gonna be uploading the backend, so and necessary libraries. All right, so and I'm gonna be doing a git push. cd cd rag system git push. There it is. So now you should be seeing exactly the same backend that I just basically was creating. This is still installing. It's taking a while, so I'm just gonna give it a couple more minutes. I'm just gonna snooze Copilot for a second, and then I'm gonna use Copilot for the Streamlit part. For the rack part, we're gonna be doing that ourselves, so we can go step by step, and Copilot does not generate everything while we are just trying to explain stuff. I'm gonna make my terminal smaller so you can see every step. And then what we're gonna be doing in here is that we're gonna be creating all of the necessary variables that we're gonna be needing, right? So all of the necessary variables that we're gonna be needing is the Mongo URI. So we're gonna be needing the Mongo URI that we already created. We also need the database name that we're gonna be fetching from MongoDB. We also need the collection name, the name of your collection, and we're also gonna be needing the Atlas vector search. So this is the name that you placed to your Atlas vector search. Mongo URI, this one, we're gonna be using the one that's on my secrets database name. Let me see what was the name of my database. So the name that I placed to my database was, let me see, Vector Store Database. That was the name that I used. So I'm gonna be typing exactly the same. So Vector Store, oh no, my bad. This doesn't go in here. Vector Store Database. And then for collection name, I selected the name Embeddings Stream. Remember that these names have to be exactly the same as you have them on MongoDB. Otherwise, it's not going to find your database name, collection name, or the Atlas vector search. For the vector search, my name is Vector Store Database. No, it's Vector Index Global Hack Week. That's the name of my index. Vector Index Global Hack Week. Okay, and then for the Mongo URI, I'm just gonna import Streamlit, and I'm gonna use the secrets tool in here. So import Streamlit as st, and then I'm gonna do st.secrets, and then I'm gonna do these and place my secrets in there, which in this case is called Mongo URI. There we go. Okay, my dependencies are literally, I'm gonna shut this down and see if it got installed. Okay, only PyMongo was installed, but what about, let me pip install Streamlit. Okay, so in Streamlit installed, and why is LangChain not being installed? Let's see, pip install, or maybe it was just taking like really long. Yeah, I think it was just taking really long to install. Okay, now we have LangChain, and what else do we need? Um, we need LangChain, Google Gen AI. Well, first let's install the MongoDB one because it's the ones that we're going to be using first. Pip install LangChain MongoDB. There we go. And finally, this one. I don't know why the requirements was completely frozen, but it should work on your end. I mean, I'm just installing them manually right now, but not sure why it was failing when I was trying to install everything like at once. Oh, why is this one not being imported? Let's see, LangChain prompts. I'm gonna look these up just to check if the library is being correct. We have a question here. LangChain, Google Gen AI. Oh, I already read this. The database name is basically in browse collections, right? Yes, you are correct. That's where you have to find it. Yep. Da, da, da. Um, in the meantime, start filling out the variables that I left in there. So the collection, the client as well, the collection name, atlas vector search name, and the database name. Okay, so in the meantime, let's continue. I think that's enough time. And please let me know if you also have like any other questions. I'll make these smaller. Oh no. Nope, nope. We don't need this. There we go. The thing is that I have my VS Code and it's really big for you to see what's going on in there. We have another question. What is Atlas Vector Search Name? That you can find it. Let me give you under search and vector search. Search. The left panel. Yeah, you can find it under search and vector search on the left panel that you have in there. Okay. So I searched and I think we are ready to continue onto the next part to start creating like our sample methods. The first thing that we're going to be doing is that we're just going to be doing the vector store. Let me swap to that tab in here. So we're going to be doing our vector store, and let's see. Let me enter here. We're going to create the first function. This is actually completed. Oh my God, this is, yeah, no, maybe that's not correct. So I'm going to snooze it for 25 minutes. That's enough. The first step that we're going to be doing here is that we're going to connect to MongoDB. So connect to MongoDB, it's very simple. You need to create your client just like any other API provider that you know. And for this, we're going to be using our Mongo client. And the Mongo client, it needs to have its connection string. So the connection string is this Mongo URI that we just basically created. So I'm just going to type in that variable in here, which is the Mongo URI that we already have. There we go. So we already have our client. And then the next thing that we're going to be doing is that we're going to find the collection and the database. So to find that, we're going to create a collection variable. We're going to use a client. And inside here, we need to pass two things. So we need to pass on the DB name, so the database name. And then we also need to pass on the collection name, which we already have in here on our variables, right? So this is to connect to MongoDB. And then the next step that we're going to be doing is that we need to define our embeddings model. So the one from Gemini. So for that, we're going to be creating another variable that's going to be called embeddings, because there is where we're going to be storing these embeddings. And we're going to be using the Google Generative AI embeddings tool that we just imported in here. So I'm going to just copy paste this one and we're going to use it over here. So Google Generative AI embeddings, and we need to select the model as it says. So for the model, if I go back to the documentation for Gemini, I'm just going to be typing these, and I'm also going to share the model that we're going to be using on the chat. It's called embeddings 001. Let me share this one with you all. So this is the embedding model that we're going to be using, and it is corresponding to Gemini. So it comes from Gemini, right? Okay, so then after doing that, let me do an enter. Once that we have our embeddings created, we need to initialize the vector store, so the Atlas vector search that we have over here. So to do that, we're going to create a variable that's going to be called vector store. And in vector store, we're going to be using the MongoDB Atlas vector search, which is this one from LangChain MongoDB. So I'm going to be inputting that one. I'm going to be opening here, and I'm going to be selecting different parameters in here. I need to pass on a collection. So the collection, we already created that variable in there, which is called collection. And then we're also going to be passing the embeddings. So embedding is going to be equal to embeddings. And we're also going to be passing the index name. So index name, the index name is in Atlas vector search variable. So I'm just going to be passing that one in here. There we go. So we have collection, embedding, and index name for the MongoDB Atlas vector search on our vector store variable. Awesome. So we already have that. And for this function, we're only going to be returning our vector store. Oh, this is not cool. Return vector store. There we go. So we already have our first function. I will commit this to GitHub so you can also see it. Let me upload these. And let me do a git push. There you go. So now you should be seeing that on the GitHub as well. Okay, so the next thing that we're going to be doing is that for our right now we know how to store the vectors in MongoDB, but now we also need to convert the text to embeddings because it's the text that the user is going to be inputting into our application. So to do that, we're going to create a new method that's going to be called ingest text, and inside we're going to be having the text content, right? And inside here, we will be taking raw text and we will be creating a document object in MongoDB. So we're just going to be storing this text as an embedding in MongoDB to have our vector database. So to do that, we're first going to do vector store. We're going to create a variable that's called vector store because it's the information that we're going to be inputting into MongoDB. And we're going to be using our method, get vector store. Awesome. Then what we're going to be doing is that we're going to create a MongoDB document. A document in MongoDB is basically a JSON object that you get to input into your database. So let me create my docs in here, and we're going to use the document attribute. And there's different configurations in here. In this case, I'm going to use the page content. Not sure what this one. Vector store. Wait, let me see. In this case, we need to create a single document. Maybe just pass the text content. Okay, yeah, that sounds fair because that's the text content that we're going to be needing to pass in there. Okay, so we have the document, and then we are going to be adding information into our vector store. So vector store, then we're going to add documents. That's to upload to MongoDB. And then in there, we need to select specifically the document that we want to upload. In this case, it's called docs, which is this one that we have in here. Wait, I'm just not very sure about this. Because this is converting. We have the vector store, adding documents. But I'm not very sure. Okay, I guess we will see if that works. Okay, and then once we added that document, then we're just gonna return true because that means that it's all set. Okay, so that is all for the second method. Let me see if there's any questions on the chat. Okay, we're good. Okay, and then the next thing that we're gonna do, which is actually the part where we are gonna be using our RAG, we're gonna be creating a method that's gonna be called get RAG response, which is the whole pipeline that we just basically went over. We're gonna be receiving a query, and the first thing that we're gonna be using is store our vector using the get vector store. So again, we're gonna create another variable, the same, a vector store. We're gonna get a vector store in here. We're gonna call that one, and then we're gonna define the LLM that we're gonna be using. In this case, we're gonna be using the Gemini LLM. So if I go up here, we're gonna be using the Chat Google Generative AI one. So let me, maybe I need to install this one. So I still don't know how. I will ask Copilot in a minute because maybe that's why this was not showing up properly. Okay, for the chat of Gemini, we're gonna select our model. In this case, we're gonna be, wait. Why is it not letting me select the model in here? This is weird. I did paste it correctly because this is supposed to be like a parameter. This is supposed to be an object, but it's not showing me like any validation. Okay, I'm just gonna assume that everything works perfectly, but I will make a note in here that this might be wrong. And we will fix it later. In here, I'm just gonna select the model. In my case, I'm gonna be using 2.5 Flash, so Gemini slash 2.5 of Flash. This is the model that we're gonna be using for our LLM. Let me paste that for you on the chat. There we go. Okay, and then the next thing that we're going to be doing is we can also select the temperature. In this case, I'm just going to leave it as it is because it's not getting me. The LLM is not being defined correctly. Not sure why. We'll see. Okay, and then the next thing, we're going to create our retriever, which is the retriever chain that we're going to be using in order to fetch the top n elements that we want to use as our context. In this case, we're going to be using the vector store that we just created. So vector store, and then we're going to do dot, and we're going to select the as retriever. As retriever, and then inside these, we're going to select our search type. So search type. This is so weird because it's appearing in there. Huh. This is super weird. Huh. To be honest, I don't know why it's showing me like the arguments, but it's not appearing in here. Okay, so let's just see search type. We're going to use, for this one, we're going to use similarity. Similarity. And then we're also going to be, we're also going to be picking, let me see. We can select the similarity score or the number of Ks that we want to use. In this case, the arguments, we're going to be using the amount of documents that we want to return, which is a K, so it's a number. In this case, we need to click in here. So search, I don't know how to pronounce that. So we're going to be using the search arguments, which in this case, we're going to be inputting the K, and the K in our case, it's going to be equal to 3. Why? Because we want to use 3 documents as context for our vector database in this case. So 3. There we go. So now this is complete for our retriever. Now we just have to do our prompt template and then just call our retriever in there. We have a question in here. Oh, we have many questions. What does the document function do? So the document is to store that in document format in MongoDB. The thing is that it's not loading me the object correctly. I'm not sure why. Yes, you can say that a document is in JSON format, and then once it is stored in MongoDB, it is stored as BSON format. If that is the case, why is it imported from LangChain out of all things? Because we are using LangChain as a connector to all of these elements. Another thing that I could do is use regular libraries like the MongoDB library. I can also use the base library for Gemini, but I'm using LangChain to maintain everything like uniform, and also because it's used for mostly all AI agents and LLM tools that are out there. I'm seeing that I have literally 10 minutes left, so I might not be able to finish all of the code. I will be finishing this function, yes, but then as for the dashboard, I will be finishing that and uploading it on the GitHub, and I will make an announcement on the server once it's done, so you can also check it out. But in the meantime, I want to make sure to finish this so we can at least have the function working and we can test it. So let's continue. So now that we have our retriever, we need to create our prompt template, which is the one that we're going to be using in order to make the prompt, so we can make the section of the context plus the prompt that we're going to be using. So for this section, we're going to be saying use the following context from the user in order to provide an accurate answer. There we go. And then we're gonna passing to know an accurate answer. All right, so that's gonna be our prompt template, and then we're gonna be fetching our actual prompt. So to do that, I'm just gonna create a prompt variable in here. I'm going to be using the prompt template, which is not being loaded correctly right now, that it's from LangChain. And I'm going to be passing on the template that we just created. So prompt template. Then I'm also going to be passing my input variables. So the input variables that we're going to be needing is number 1, the context, and number 2, the question. So question. And then we're also going to be passing this has to be an array. So we're going to be passing a context, and we're also going to be passing question. Right, there we go. We have the prompt now. So now it's time to create our chain. So the Q&A chain that we're going to be creating. And for these, we're going to be using the retrieval Q&A from... Why is it not loading? I hate when I actually don't know. Yeah, because these three are not loading correctly, and that's why I'm not being able to see like the different methods generated from that library. Might be that. For LLM, we're going to be using the LLM that we just defined earlier, which in this case is the Gemini one. So we already have that one. Then from the chain type, it can be whatever. We're just going to be passing on stuff. And then for the retriever, we already have that. So that's going to be equal to retriever, which we already defined earlier. For the return source documents, we're going to be passing on our documents that we already have. No, return source documents. No, might not need this. I think that's enough. And then the last thing that we're going to be doing is that we're going to be generating our actual response. So the response is going to be equal to the chain that we just created. So the Q&A chain, we're going to invoke that thing, and we're going to do our query inside here. Query, and my query is going to be having our actual our actual query that the user is going to be inputting when they do the get rag response, and we're going to return our response. And this has an error. There we go. All right, so let me upload these to GitHub and finished. So you can also see it. And I'm going to do a git push. There it is. All right, so hopefully with this, we finished most of the backend. I didn't get to test it. I'm getting these warnings in here. I need to check how to install these libraries correctly. And then I'm also going to be adding more information in here in order to make the Streamlit dashboard. I already pushed all of the code into the GitHub, so you can also see it. Let me stop sharing this one and start sharing the other one. Okay, I think my screen lag again, so I'm gonna be needing to log out super fast, and then log in again. I'll be back in 1 minute. Okay, there it is. Okay, so sadly I wasn't able to finish all of the code. Honestly, I think I spent a lot of time explaining like all of the technical concepts. Hopefully you were able to understand all of the technical concepts. I will be uploading the rest of the code on the GitHub probably at night because I have to do other stuff right now. I will be sending out a Global Hack Week announcement once the project is done, so you can also finish in there. And then let me also share a last thingy in here. Let's move on in here. All right, so if you like this stream and you would like to leave some feedback, please make sure to fill out this feedback form. It's super short. It should be like less than 5 minutes long. I'm sending out the link in there. I also brought my own queen bee in here, which is a bee that's like a queen. I wanted to show you all. It's really nice. Yay. So yeah, I promise you I will finish these by today, so you can have your finished project. If you want to do contributions into my GitHub repository, you are free to do so. You can open up a pull request, and you can send me a message, and then I can review it, and then I can merge it, so you can have an open source contribution on that repository if that's something that you are wanting to do. And yeah, thank you very much. I will be seeing you all tomorrow.